So we're talking about probability today. And if I roll a die here, it's a 3. Raise your hand if you're in the running still. Ooh, there's a bunch of people. And now I'm flipping a coin. And I got a heads. Who in here guessed heads? 3. And that's more. 1, 2, 3, 4, 5 people. That's way more than it should be. What do you mean it should be? Well, let's think of it this way. What's the probability that they were going to guess that right? I had kids guess ahead of time what was going to come up. And, well, what's the probability you're going to get the coin part right? 1 and 2. Times, note that, you multiply probabilities. You almost never add the fractions, but you multiply the fractions all the time. You know why? Because if you add for a bunch of fractions, do you get it to be pretty easy to get up over 1.0 if you're adding a bunch of fractions together? Yeah, and then isn't probability like have to be 1 max? All right, so we don't add much when you're talking about fractions. We almost always do multiply. When I say almost, it's because, yeah, sometimes you add the tops into the tops of probability problems like this. Oh, you can't see that. I'm going to pause for a second while I put that up on the board. Okay, so you are going to multiply probabilities, but you almost never will add fractions. You can add in the top part of a fraction, but not the whole fractions. So then there's a 1 in 6 chance that you're going to get the die right. You multiply them and you get 1 in 12. I heard some kids saying that already. That's awesome. But how many of you are there? If there were 12 of you, I would have expected 1 kid to get it right. There's like 24 of you. I'd expect 2 kids to get it right. But do you get that there's randomness involved? You can't just say that when I flip a coin 100 times, it's going to come up 50 heads and 50 tails. Know what I mean? Sometimes it doesn't come out that way. There is something called the law of large numbers, though. That if I do 1,000 coin flips, it's much more likely to get close to 50-50. You see what I'm saying? And one more time, is 50-50 a probability? No, those are called odds. We'll talk about the difference to that later. All right, so probability is what you want over what's possible. And that's going to keep coming up over and over again. What's possible is really key today on today's charts and stuff that we do. All right, so what we want is we only had one of the 2 possible things. We only had one number out of the 6 possible things. What we wanted was on top. What was possible was on the bottom. All right. I'm going to pause for a second while we bring in another picture here. All right, is this a good enough representation where you could say that that's marbles in a bag? And that there's 6 marbles in a bag, 3 green and 3 blue. Oh, 4 blue. Are you with me? Okay, how about if I throw in 1 red one? 1 special red one. I reach into the bag and I grab. What's the probability of getting a red? 1 out of 8. Good. What's the probability of getting a red or a blue? Notice I'm adding in a fraction, but I'm not adding fractions. You get the difference there? 1 plus the 4. And or means add. I want you to keep remembering that. That's one of those ones that I'm going to keep saying over and over again. What's or mean? And you're going to say add. So should the probability go up or down if I say the person has to have a cat or a dog? Up, because they have, anybody who has a cat, you win. Anybody has a dog, you win. So if it's a dog or a cat, the probability went up. You added on the top because there's more things that you want. How many of you would have the cat? Raise your hand if you're the cat people. Have a cat. Only 1? Seriously? Okay, how about the dog people? And that's a huge ratio of dogs to cats. All right. So, yeah, you dog people, but I really like cats, just so you know. And how many of you actually have cats and dogs? Ah, there's the combo people. All right. Then why didn't you raise your hand when I said, do you have a cat? It's interesting. Don't think of yourself as a cat person? 3 people had a dog and a cat. All right, so if I say, do you have a dog or a cat? Well, then you could raise your hand if you had a cat or a dog, and so it increased your probabilities. So or means add. All right, how about if I say, I reach in and I get a green and a blue. Well, and that's, if you're only drawing one marble, that's not even possible. But when you draw two marbles out, that's where life gets more complicated. And we are going to do problems like that, but not today. All right. So today is more about reading charts and graphs. Let's do a quick survey here to get charts and graphs of you guys. There's male people in here and female people in here, and people that have a piano and people that do not have a piano. All right. Would you please raise your hand if you are a male person and have a piano in your house?
What about a keyboard?
Good question. I'm going to go with actual piano because I think it's going to make a smaller number. Actual piano. 1, 2, 3. Just 3. All right. You're a female person and you have a piano in your house. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Interesting. How about not? You're a male and you do not have a piano in your house. 1, 2, 3, 4, 5, 6. And last but not least, female, and there is not a piano in your house. 1, 2, 3, 4, 5, 6, 7, 8. Awesome. Now, do you get that there's also a category we could do called totals? I could get the total pianos, which would be 13. People in here have a piano. Not pianos, 14. Male people, 9. Female people, 18. Some of you are like, wait, there's that many more girls than boys in here? There is. Okay. Then let's say we now needed a total of the totals. Would it be a nonsensical number to add up this and this and this and this and put them all right there? That wouldn't make any sense, would it? All right. So don't just total everything up. But what if I asked, what's the probability for grab a random person that they have a piano at their house? 13 out of, and then you added up the total people and made it 27, right? This adding this way is also 27. We don't want to add those together and make 54. That wouldn't make any sense. It's 27 in either direction. Okay, then, what if I only ask the piano people? I get all the piano people together, and there's how many of them? 13. What's the probability that I would end up picking a random one and getting a guy? Why is it 3 out of 13 instead of 3 out of 27? 13 were the only ones that I could possibly pick. It's always what's possible that it's out of. All right, now try and answer this question. Leave it as a fraction. You ready? If I'm picking from people that do not have a piano, what's the probability it will be a girl? If I'm picking from people who do not have a piano, what's the probability that I will get a girl? A female person. Well, as soon as I said I'm picking from the people that do not have a piano, only this part of the chart matters. Everything else is gone. Do you get then, if you narrow it down like that, the only numbers you could pick are 6, 8, and 14? See how that makes it a lot easier? Because now if I just go, okay, female, 8, 8 out of 14. See how easy it is? What was the key? What changed was not what's on top. What changes usually is what's possible. All right, so we're going to go and do one more like that. Let's say from the guy group, only the guys are asked, what's the probability that a guy that I ask has a piano? I'm only asking from the guys. And I grab one of them and I say, hey, you, do you have a piano? Hey, you, do you have a piano? What was the probability that was going to happen? Notice I only asked about the guys, so therefore I'm only using this and everything else is gone. Now it's easy. 3 in 9 chance. Make sense? All right. This is called probability tables. And it's all about what's possible. Last thing I have is an or question. Have I patterned you well enough that as soon as I say or, you think what? Add. Good. All right. What if I grab a random guy and I win if he has a piano or not? What? Piano or not? The probability is 100% or 1.0. Either way is an okay way to say it. Because I win if he has a piano or not, which makes 9, out of how many were possible? 9. So it was 3 plus 6 out of 9, which is 9 out of 9, which is a 100% chance that I win. Okay. All right. Let's get to your homework. The homework for tonight is easy enough. I'm going to start it with them, and then they're going to have to finish the whole thing. So that's all I have for the video for today. And I wasn't